In 10.3, what we're going to take a look at is now some polar coordinates. And to get us going, we're going to start off with some vocabulary. So the first thing you're going to notice, if we look at a polar coordinate, it's each point on a plane that's determined by a distance from a reference point and an angle from a reference direction. When we graph this, we're looking at r, comma, theta. So we're going to be looking at r as being the radius from that origin point, and theta being the angle that it creates as it comes out. So it's still referencing to our triangles like we saw through our trig. Now I do have a nice little polar coordinate graph down here, so let me label a couple of things on it. This center point here on our Cartesian plane would have been our origin, but we call this the pole, kind of where everything centers from. This axis here is our polar axis, and this entire thing we call our polar grid. So just kind of some terminology to get us going. So typically we look at it, we say we're going to do an x, y coordinate. So we go over on our x, then we go up to our y. Now we're going to do it in terms of radius and angle. And so what you want to do is you want to find your angle first and then go out to your radius, however many units. And so I have an example down here, and you can see it on your notes that you've pre-printed here. I made examples that says to plot the point 3 pi over 2 on a polar grid. So I'm going to use this polar grid here as we plot part A and part B for examples 2. So what you're going to do is you're going to start with, I know this seems unusual, but you're going to start with your theta. So I'm going to go up to pi over 2. So you can see this here is my pi over 2. And then I'm going to go out 3 units. So from the pole, I'm going to go out 1, 2, 3. And this would be the point 3 comma pi over 2. So it's kind of unique because typically we start with this first value, but we're going to start with our angle. And then you can see these are concentric circles that are going out, and these are your units that you're going out. We just have a unit of 4 on this graph here. Let me also show you this negative 2 pi over 6. So I'm just going to write out here to the side so you can see my polar grid as I graph. So I'm going to go to pi over 6. So I'm going to be somewhere on this one. And then from my pole, I need to go negative 2 units. So I'm going to have to go backwards. 1, 2. And so I am on the circle of 2. But since it is negative, I had to go backwards. So you can see here's this whole bar as pi over 2. So this could even be the same point as 2, 7 pi over 6. And so you will have some multiple options for different points, just like you've seen as we graph through things, that we can have different values represent the same thing, positive, negatives, etc. So we're going to pick up our polar grid, and as we look at our polar grid, we're going to notice some key things. We are going to have to convert from some coordinate pairs, such as information of x, y, into these polar coordinates, and so that's what I'm going to work with next with part 3. So part 3, I want to look at converting the polar coordinates to rectangular coordinates. So we get a nice box here from our textbook. So it says to convert your polar coordinates r comma theta to rectangular coordinates x, y, we're going to use this information. Now where does this come from? This right here is your cosine in your ratio, and here's your sine ratio, relating back to your SOHCAHTOA, how you set up your triangle and find your different values. They're just using x's and r's, relating our x, y, and r of our radius. Then what they do is they multiply both sides by r in order to get x equal to r cosine theta and y equal to r sine theta, and you're going to use this quite frequently as we move through this chapter. And so then it says how to, given the polar coordinates, r theta, write them as x, y, evaluate your cosine and sine, multiply your cosine by your r to find your x, and then your sine by your r. So let's just kind of jump in and see what we can do. So this is my r and this is my theta, and by the end of this example, I would like to figure out my x comma y. So the first thing I want to do is I want to find my x. You'll notice from up above here, I want to work with x equal to r cosine theta. So I'm going to say x equals r cosine theta. The more I see it, hear it, do it, the more I'll retain it. And so I'm going to say x is equal to, here's my r value, so it'd be 3 cosine of pi over 2. Now, we're familiar with working with cosine of pi over 2, so you reference your unit circle. So this gives me x to be 3 times cosine of pi over 2, which is 0. 3 times 0, so I just get 0. So in terms of my x, y, or the rectangular coordinates I want, I get a 0 value for x. I'm going to do the same thing for y, so I'm going to say y equals r sine theta. So this gives me y equal to my r being 3, sine of pi over 2. So again, unit circle, sine of pi over 2 is equal to 1. So I get 3 times 1, which is just 3. So now I've been able to take the coordinate 3 pi over 2 and transfer it into a rectangular coordinates of 0, 3. And what's interesting is if I come over here and I look at 0, 3 on my coordinate plane, I would be at 0 and up 1, 2, 3. So this would be the point 0, 3. Now if I come over here and talk about my polar grid and graph this, this would be a radius of 3 but an angle of pi over 2. So I first graphed pi over 2. So that would be up here on the vertical axis. And then 1, 2, 3. So you can see the similarities of the placement of this point in relation to my polar grid and in relation to my rectangular coordinates. So there is a simulation there between those two. Next thing I want to do is I want to write the polar coordinates of -2, 0 as rectangular coordinates. So again, this is my r and this is my theta. I'm going to follow the same steps as we saw in the previous example. I'm going to do r cosine theta, and I'm going to be looking at y equals r sine theta. So x is equal to r, which is -2, cosine of 0. So x is equal to -2. Now then, cosine of 0, unit circle, is just 1. So I get x to be -2. So over here to the side, I'm looking for my xy coordinate. This would be -2. Then I'm going to say y is equal to r, -2, sine of 0. Again, unit circle, so I say -2, sine of 0 is actually 0, so I get 0. And so again, if you look at how these are graphed on your rectangular coordinates and you look how they are graphed on your polar grid, you'll see some similarities between their placements on the two different graphs. So we've got an idea here on how we can go from our polar coordinates into our rectangular coordinates. And so let's kind of move forward with our examples. On to the next page, you'll see for part 4 here, we're going to be converting from rectangular coordinates to polar coordinates. So we've gone this direction in part 3, so now we're going to go the opposite direction. You'll notice some kind of familiarities here with this next gray box. It says, notice when you're converting from rectangular coordinates to polar coordinates, some information. We already know this information from our previous gray box, and we converted it into solving for x and y. We're going to remember our Pythagorean identity, where this is our x, y, in order to get our r squared, and then we're going to bring in tangent with this one. So with these first two, you use these a lot to go from polar to rectangular. These bottom two, you're going to go from rectangular to polar more easily with them. So let's just kind of look down at the example and kind of work through this and see what we can figure out. So the first thing I want to do is I want to kind of take this all in, and I want to say, okay, I'm converting the rectangular coordinates 3, 3. So I want to consider their placement and what quadrant this is in and make sure I'm doing this correctly. So this is my x value, this is my y value, my goal is polar, and here's my point here, 3, 3. So the first thing I'm going to do is I'm going to find my r value. So I would say r squared is equal to the square root of x squared plus y squared. Excuse me, r is equal to that. Just using your Pythagorean identity from above, and I've square rooted both sides. So r is equal to the square root of 3 squared plus 3 squared. So I actually get the square root of, let's see, 9 plus 9, or square root of 18. And then reducing that down, that gives me 3 square roots of 2. So r is equal to 3 square roots of 2. So in terms of my polar coordinate being my r and theta, I now know my r to be 3 square roots of 2. So that's pretty straightforward, and that's the first part that a student may get pretty easily. But the other part that we need to consider is figuring out the angle. So what we're going to do is, instead of using a cosine or sine relating x's and r's, I'm going to use tangent because I know for sure what my x and y are. And so I'm going to say tangent of theta is equal to y over x. Well, we know y and x from the given, so I would say tangent of theta is equal to 3 over 3, or just 1. So theta would be equal to arc your tangent to move it over, arc tangent of 1, and that gives me pi over 4. So my coordinate would be at 3 square roots of 2, comma, pi over 4, which makes sense for what we're working with, because if I started here on my pole and I went up my angle to pi over 4 and then out 3 square roots of 2 units, I would be able to get to that value. Now, we have from polar to rectangular coordinates, we have from rectangular to polar coordinates. The last thing we need to consider is working with some of their equations. And so on our next example here, we're going to do just that. So we're going to say, write the Cartesian equation x squared plus y squared equal to 9 in polar form. So a couple of things that I'm going to consider is I'm going to look at x equal to r cosine theta, and then I'm going to look at y equal to r sine theta, and I'm going to use these values in order to convert my equation. Before we just used them and we said, you know what, when we're working with this, let's just transform our x's, transforms our y's, and we got singular values. Now I'm going to use those same substitutions in order to transfer my equation. So I'm going to say r cosine theta squared plus r sine theta squared equal to 9. So working with this, I can square these individually, so that gives me r squared cosine squared theta plus r squared sine squared theta equal to 9. I'm going to factor out the r squared, leaving me with cosine squared theta plus sine squared theta equal to 9. You'll notice there's a Pythagorean identity. That equals 1. So I get r squared equal to 9, square root, and I get r equal to plus or minus 3. Now what's interesting with this is, again, let's consider our two coordinate planes here. Let's look at our xy axis, and let's also look at our polar grid. When I consider both of these graphs look very similar in what they look like. On your xy axis, this is actually a circle with a radius of 3. And then on the polar grid, r equal to plus or minus 3 is just looking at your concentric circles would be this third circle out here. Whether it's positive or negative, it would still create the same circle. So it's really interesting that this is the same equation, and graphically it creates the same picture whether I'm on my xy axis or my polar grid. So we're going to do the same thing with this one. It has a little bit more letters to it. And I want you to consider a couple of things as we work this. Remember on previous pages here, we also determined that r squared is equal to x squared plus y squared. We've kind of proven that here in this previous example. So instead of going through the direct substitutions of x and y, I'm just going to say, well, that's r squared. And that's equal to 6y. Now I also need to deal with this y, so we know y is equal to r sine theta. So I'm going to say r squared is equal to 6r sine theta. So this gives me r squared equal to 6r sine theta. I need to solve this out. And so this gives me, let's see, I can move this over here. So I have r squared minus 6r sine theta equal to 0. Factor out your r. And then because I have r times something to give me 0, I could say, well, r could be 0, or r minus 6 sine theta could be 0. This gives me r equal to 6 sine theta. And this would be the equation that would compare to this. R equals 0, if you think about your polar grid, that would just be at your pole, so that does not create the same equation as this one. But r equal to 6 sine theta, this creates the equation that I need. Now in this last one, we're going to be looking at y equals 3x plus 2. We're going to have to do a little bit more with this one. So let's consider some things that we know. We know x is equal to r cosine theta, so I can see that being beneficial here with this x. And I know y is equal to r sine theta, so I have a substitution here for this y. So we're going to convert it into a polar equation. And so this gives me r sine theta equal to 3 times r cosine theta plus 2. Start combining like terms, moving things around. The parentheses doesn't protect anything in this, so I subtract it over to get all my r's together. So I get 2 equal to, let's see, this is a 1r minus 3r, so let's see, r sine theta minus 3r sine theta. Factor out your r. Divide by this to get r by itself.